Welcome to Universe Secrets, where we embark on a visual journey to uncover the hidden origins of our vast cosmic home. For generations, humanity has looked up at the stars and asked the single most profound question: how did the universe begin? Most people imagine a giant explosion, a sudden burst of energy and matter erupting from a single point into empty space. This popular idea focuses on the singularity, a point of infinite density and heat where the laws of physics break down. However, modern physicists largely reject this singularity concept, suggesting our understanding of the universe's actual beginning is still far from complete. To understand why, we must look back at history, starting with Isaac Newton, who believed the universe was static and eternal. Newton viewed space as an unchanging stage where time ticked forward constantly, regardless of the events happening within the cosmic theater. Then came Albert Einstein, whose general relativity revolutionized our view, showing that gravity is actually the curvature of space and time. Einstein proved that space is not a fixed stage, but a dynamic fabric that can stretch, bend, and evolve over time. It was Georges Lemaitre who first proposed that if the universe is evolving, it must have started from a primeval atom. He suggested that the universe expanded from a tiny, hot state, a radical idea that challenged the static model of cosmology. The evidence arrived when Edwin Hubble observed distant galaxies and noticed something strange about the light they were sending toward Earth. Hubble discovered redshift, proving that galaxies are moving away from us, which means the fabric of space itself is expanding. Imagine a balloon being inflated. As the surface stretches, every point moves away from every other point, just like our universe. If we rewind this cosmic movie, everything draws closer together until the entire universe is compressed into an incredibly dense state.
A sound resembling a
Ironically, the
bang
term Big
suggests
Bang
a
was coined by
beginning,
Fred
which is
Hoyle
a
to mock the
fundamentally
theory, but the name
unsatisfactory
stuck
concept,
and
I must
became
say.
legendary.
Look at this spike
In the
right here.
60s,
It's
Penzias and
off the
Wilson
charts,
accidentally discovered a persistent background
but it
noise
doesn't
while
match the
using a large
expected
radio
frequency
antenna
at
for
all.
communications. They tried removing pigeon droppings and checking circuits, but the noise remained. It was the cosmic microwave background, or CMB. This radiation is the afterglow of the Big Bang, a snapshot of the universe when it was just a baby. For the first few 100,000 years, the universe was so hot and dense that light was trapped in a plasma fog. When the universe cooled enough, atoms formed, the fog cleared, and light could finally travel freely, creating the image we see today. However, the CMB presented a major problem. It was too uniform. The temperature was almost exactly the same in every direction. Regions on opposite sides of the sky were too far apart to have ever exchanged heat or information since the beginning. This is the horizon problem. How could the universe be the same temperature everywhere if its parts never touched each other? Another issue was the flatness problem. The universe appears perfectly flat, balanced on a razor's edge between collapsing and expanding forever. Enter Alan Guths in 1980. He proposed a solution that modified the Big Bang Theory: cosmic inflation. Guth suggested that a fraction of a second after the beginning, the universe underwent an extremely rapid, exponential expansion phase. This expansion was faster than light, stretching a subatomic speck into a macroscopic cosmos before the standard Big Bang even started. Inflation explains the flatness. Just as stretching a wrinkled sheet makes it look flat, inflation smoothed out the curved early universe. It also solves the horizon problem. Everything was in contact initially, normalized in temperature, and then ripped apart by inflation. But what caused this inflation? Physicists believe it was a scalar field, often called the inflaton field, holding immense energy. As the inflaton field dropped to a lower energy state, the expansion stopped, and that energy dumped into creating matter. This moment, called reheating, is what we traditionally think of as the Big Bang, the birth of a hot, dense universe. Inflation also explains the origin of structure. Tiny quantum fluctuations in the early universe were stretched to cosmic sizes. These microscopic jitters became the seeds for galaxies. Without them, our universe would be a boring, empty soup of gas. Observations of the cosmic microwave background have confirmed these predictions with stunning precision, making inflation a cornerstone of modern cosmology. However, inflation leads to a mind-bending consequence. If inflation stops here, it might continue eternally in other parts of space. This is the theory of eternal inflation, suggesting our universe is just one bubble in a vast, ever-expanding cosmic multiverse. In other bubbles, the laws of physics could be completely different. Maybe gravity is repulsive, or light travels at different speeds. This implies that everything that can happen has happened, or will happen somewhere in this infinite expanse of bubble universes. But where did the energy for inflation come from? Can you really get something from absolutely nothing, as the theory suggests? In quantum physics, there is no such thing as empty space. Even a perfect vacuum is filled with quantum fields. The universe might have zero total energy. The positive energy of matter is exactly canceled out by the negative energy of gravity. Think of it like digging a hole. The dirt you pile up is matter, and the hole is gravity. The sum is zero. Stephen Hawking proposed that asking what came before the universe is like asking what is north of the North Pole. There is nothing north of the North Pole. Similarly, time as we know it may not exist before the Big Bang. If time itself began with the universe, then the concept of a beginning becomes a limitation of our human language. Science continues to rewrite the story. What we consider facts today might be seen as myths by future generations of scientists.
The energy spike on
Experiments
channel
at
7
places
is
like CERN
unprecedented.
are trying to recreate the conditions of the early
Reroute
universe
the
to
data
test
stream.
these
We need a
bold
closer look at
theories.
that vertex.
By smashing particles together, we peer back in time, hoping to catch a glimpse of the forces that shaped our reality. Telescopes like James Webb are looking further back than ever before, hunting for the very first galaxies to light up the dark. These ancient signals carry the secrets of the early universe, helping us refine our models and discard incorrect assumptions. Some physicists look to string theory, suggesting that our universe is a membrane floating in a higher dimensional space. In this view, the Big Bang was not a beginning, but a collision between two universes in a cyclic cosmic dance. This cyclic model suggests the universe has no beginning and no end, just an eternal rhythm of death and rebirth. Nobel laureate Roger Penrose champions this idea, looking for fossil evidence of previous universes hidden within the CMB radiation map. While controversial, these ideas remind us that our standard model is likely just an approximation of a deeper truth. From the smallest quantum particles to the largest galaxy clusters, the story of the universe is written in every scale. We are part of this story. The atoms in our bodies were forged in the hearts of stars in ancient explosions. We are the universe experiencing itself, trying to understand the incredible sequence of events that led to our existence. The journey from Newton's static stage to Guths' inflationary multiverse shows how much we have learned in just a few centuries. Yet for every answer we find, 10 new questions arise. The nature of dark energy and dark matter remains elusive. We realize that visible matter makes up less than 5% of the cosmos. The rest is a dark mystery. We are still pioneers standing on the shore of a vast ocean of ignorance, eager to set sail and explore. Future technology and new physics may one day reveal what happened in that very first fraction of a second. Until then, the Big Bang Theory, augmented by inflation, remains our best map of the history of everything that exists. It tells a story of evolution, from a hot chaotic soup to the majestic structured universe of galaxies we inhabit. It is a story that includes the formation of stars, planets, and eventually the complex chemistry that allowed life to flourish. So the next time you look up at the sky, remember that you're looking at a fossil of creation. The light hitting your eyes has traveled for millions of years, carrying the legacy of the universe's spectacular and violent birth. We are merely travelers on this river of time, attempting to map the source before the current carries us further. Mathematics gives us the language to describe the cosmos, but the beauty of the universe transcends equations and numbers. The feeling of awe we experience is a reminder of our connection to the grand design of this cosmic reality. As we zoom out, Our daily problems seem insignificant compared to the vastness and mystery of the space surrounding us. The cosmic web looks eerily like a brain's neural network, hinting at patterns that repeat from the micro to macro. Science answers the how, but the why remains a philosophical question that each of us must answer for ourselves. Whether through science, religion, or art, the quest to understand our origins is what makes us fundamentally human. We keep lighting candles in the dark, pushing back the boundaries of ignorance one discovery at a time. From dust to planet, from simple cells to conscious beings, the universe has gone to great lengths to create you. Take a moment to appreciate the improbability of your existence in this vast, expanding, and mysterious universe we call home. Like shooting stars, our time here is brief, but our capacity to understand and wonder is infinite and enduring. As technology advances, who knows what secrets we will uncover next? The golden age of cosmology is happening right now. Perhaps one day, we will not just observe the universe from afar, but travel through the fabric of space itself. Until then, we rely on our minds and our machines to explore the edges of reality and the beginning of time.
See?
Tapping the
The
board.
torch is being
If we
passed
apply
to a
the
new
variable right
generation of
here,
thinkers who will challenge old ideas
that
and
resolves the
propose new
anomaly.
ones.
We did it.
As Carl Sagan once said, we are a way for the cosmos to know itself. We are star stuff, pondering the stars. Every time you learn something new about the universe becomes a little more conscious of its own existence. We have covered the Big Bang, the rapid expansion of inflation, and the mind-expanding possibility of an infinite multiverse. Which theory do you find most compelling? Do you believe in the multiverse, or do you think our universe is unique? We want to hear your thoughts. The comment section is open for debate, discussion, and your own personal theories. If you enjoyed this journey through time and space, please support us by hitting that subscribe button right now. Don't forget to turn on notifications so you never miss an episode as we continue to explore the universe's secrets.
Check out our other videos where we dive deep into black holes, alien life, and the future of space travel.
Your curiosity fuels this channel. Thank you for spending your valuable time with us on this intellectual adventure. The universe is vast, and our journey has only just begun. There is always more to discover beyond the horizon. Stay curious, stay wondering, and keep looking up at the stars. The answers are out there waiting for us. Thank you for watching Universe Secrets. Subscribe now to join our ongoing quest for knowledge and unravel the cosmos with us.